are grouped in a purple box. A group can be labeled. Right click on the group and you can type a title. Now this group is labeled. The group can have different display modality, for example, bubbles. As you can see, if you click on an element, you can move it inside the group, and if you click on the group, you move all the elements joining the group. A different visualization mode is rectangle outline, similar to the blob but with square shape. But I prefer the box outline mode. It's more compact. But you can change the color as well. And this is useful to a fast visual recognition of functional sequence in the algorithm. Now, if you want to remove an element from a group, you have to select the element, right click on the group and click on remove component from the group. If you want to add the element, you have to select the component, click on the group, add group. And to dismiss a group, right click on the group and then select ungroup. Now let's go back to this lesson topic. Select perspective view in Rhinoceros. The perp frames component is useless now, so we can delete it. Now we want to move this cross-section, triangular cross-section, to the end point of the curve. To do this, we need the move component. The parameter of move component are a geometry and a vector. The geometry is obviously a triangle, so you can connect the triangle with move. By default, the vector is a vertical vector that moves 10 units vertically. But we want to custom our vector, so we need vector to point. You can find it under vector, submenu vector to points. Move is under transform, Euclidean move. So, to generate this vector that goes from the starting point to the end point, we can use the two original points of the catenary, and we can connect this new vector with move. And as you can see, now we have a copy of this triangle on the end point of the catenary. Someone asked me how to sort out an algorithm. For example, in this situation we have several wires that cross one each other. So a solution is to click on a parameter, on a plug parameter, select wire display, and then hidden with right click. As you can see, the cable disappears and the Wi-Fi symbol appears. Now the algorithm is more tidy, but if we click on the component, we can still see where are the cables, where are the wires. If we want to see again by the default mode, right click on the parameter, wire display, default. So now let's go back to the geometry problem. Now we have these two triangles. We need to rotate it to rotate to the last one. So select rotate. You can find rotate under transform, Euclidean rotate, as you can see. We need the first parameter we need is geometry. The second is angle in radians. And the third one is the reference plane. By default, the plane is the word XY. So we need to plug the endpoint with the rotate component. So now the component knows that the origin of the reference plane is in the endpoint of the catenary. Now we can, as you can see, now we can connect the geometry with rotate. And as you can see, rotate as move as well, generate a copy of the geometry. Now with a slider and a radiance component, we can set the angle. Radiance is under maths, trigonometry, radiance, and it converts degree in radians. So connect 180 degree with radians and connect radians with the angle parameter of rotate. Now turn off the original geometry, and here we have our, we can set hidden the plane so we can have a clean algorithm. Here you can see the Wi-Fi symbol. Now we have to plug the cross-section parameter with both our triangle. So with the merge component, connect both the first triangle and the rotated one with the section parameter of the sweep component, and go to front view, and as you can see now the end of the sweep is perfectly parallel to the world XY plane. But we have another issue, that as you can see in this picture, the top of the arch is smaller than the base, so we need a third reference plane here in the middle of the arch. So to do this, to place a new cross section right in the middle of the catenary, we will use the component orient. Orient needs a geometry, the first reference point, the first reference plane, and a second reference plane that is the one where you are going to locate the geometry. So to generate this new plane, we will use a perp frames component. Now connect the catenary. Perp frames is under curve, division, perp frames. Orient is under transform Euclidean orient. As you can see, go to perspective view to have a better view of the situation. Perp frame generates several frames following the curve that are perpendicular to the curve, and uses each of this plane uses the tangent to the curve as normal. We need just one plane, so we are going to divide the curve in two sections, and as you can see, the perpendicular frame generates three frames, one at the start point, one at the end point, and one in the middle. To select the one in the middle, we will use list item. List item is under sets, list item.